Let's take a look at finding the intersection of two lines. Graphically, when you have two lines and you're solving to find the intersection, you're looking for this point, some point that lies on both lines or makes both of them true. So finding this guy is your solution. You could also have the case where you have two lines and they're parallel, so there is no point in common. So this guy would have no solution here. And then the final case is if you have a line and then the second line they give you is the exact same line. Well, then every single point on those lines is the solution because they have them in common. And so here you have infinite solutions, no solution, one solution. Those are the three cases for finding the intersection of two lines. So let's go ahead and do this algebraically, because it's rare that we actually find them graphically. Remember, we're looking for some ordered pair, x, y, and I'm going to put numbers in there. And this is a point that's in common to both lines. So if that's the case, both of these are solved for y already. That means those y's have to be equal to each other. So if the point lies on both lines, that y has to be the same number. Let's go ahead and add x and subtract 3 from both sides. Adding x to the left, you get 2x minus 3 gives you just 2x. On the right, you add x, the x's go to 0. 5 minus 3 is 2. Let's go ahead and divide both sides by 2, and that gives us x is 1, and that's our x value. Now let's go ahead and substitute back into one of the equations. I'm going to use the one on the left. And when I do that, I substitute a 1 in. 1 plus 3 is 4. And so I find 4. Now, your question may be, why can't I use the one on the right? And the answer is, well, you could. Y equals negative x plus 5. Put your 1 in there, negative 1 plus 5, and you still get 4. And it makes sense, right? Because this point has to be on both of these equations. So when you substitute this in, it makes both of them true statements. So our solution to this system is that you have 1 comma 4. Now let's go ahead and do it when these equations are both not solved for y. You could do that and move this over, divide by negative 1, move this guy over. So that is possible to do that, then set them equal to each other. But we could also use what we call elimination, because this is negative y and positive y. If we add these two equations together, these y's add to 0, and you get 5x equals 10. Divide both sides by 5, and you get x equals 2. And so with a 2, we just found the y-coordinate of our solution. We're going to find the x-coordinate the same way we did before. I'm going to use the one on the right. 3 times x plus y equals 4. X is 2, so 3 times 2 plus y equals 4. That's 6. Subtract 6 from both sides, and you get negative 2. And so our solution is negative 2 for y. Now we could go ahead and put this 2 in here as well. 2 times 2 is 4. Subtract 2 from the other side, you get negative y equals 2. Divide both sides by negative, and you get y is negative 2, the exact same answer. And so this is the solution to this system. So this point lies on both of those lines. Let's go ahead and do one more. This one looks like the last guy, and they look a little funky, right? Let's go ahead and use elimination again, and I'll show you a technique. We can multiply this guy by 2 and then add him here so that we can add down. When you do that, 2 times 3x is 6x, 2 times y is plus 2y, 2 times 4 is 8. That's the most. Make sure you hit that right side. Add down. What's happening? These both add to 0, so you get 0 equals 18, right? That is never true So that means there is no solution. No solution means these lines never touch. So what does that mean to us? They must be parallel. So does that make sense? Let's go ahead and try this another way. We could rewrite both of these equations. So I'm going to squeeze this in here. On the left, negative 6x. Let's add 6x to both sides. So you get negative 2y equals 6x plus 10. Divide by negative 2. Y equals negative 3x minus 5. So that's the left-hand side. We're just rewriting them. That's it, folks. We're not doing anything else. And on the right-hand side, let's subtract 3x from both sides. And you get y equals negative 3x plus 4. What do you notice about these two equations? Y equals same slope, different y-intercepts, different y-intercepts. So if you rewrite these, you can see in slope-intercept form that they are indeed parallel but different intercepts. If you're asked to show it algebraically, though, you got to go through this where you use some algebraic process for showing that you have no solution. And so this is the process you would go through. The last solution was when every point on there is a solution. So when the lines are the exact same, then here, instead of something not true, you would get the exact same number. And you could go ahead and manipulate them around, and you'd see they're the exact same line. So that's it. Hope you're having a great day.